Well, in the last video, we did a sum and quotient on two polynomial functions, and this time I'm going to do one that's maybe a little bit harder. So here I have not polynomials, but I actually have rational functions, or fractions in other words. I still want to find the sum and the quotient of these two functions. So that's what we're looking at here. So if I wanted to talk just about f plus g of x, again, that's just the function f of x plus the function g of x. And f of x is represented by 9x over x minus 4 plus g of x, which is 7 over x plus 8. Now, before you go any further, you have to remember, how do I add fractions? If I add or subtract two fractions, I have to have a common denominator. So we don't have that in this case, and we must create a common denominator. The easiest way to create a common denominator is to take the two denominators that you see and multiply each fraction by the opposite denominator. In other words, I'm going to multiply this fraction by x minus 4 over x minus 4, and I'm going to multiply this fraction by x minus 8 over x minus 8. Because when I multiply, get rid of that. When I multiply x minus 8 times x minus 4, that's one denominator, and that's going to be exactly the same. Oh, it's not minus 8, I'm sorry. It's x plus 8. That's going to give me two denominators that are going to be exactly the same. So let me write this as 9x times x plus 8 plus 7 times x minus 4 all over the common denominator of x plus 8 and x minus 4. So I can, when I add two fractions, you may not remember this, but when you add two fractions together, we actually write them over the same denominator, but we're only adding or subtracting their numerators. So all I've done from this step to this step you're seeing here is rewritten them as over a single denominator and just kind of squished their numerators together. Now let's simplify that numerator. I'm going to distribute 9x, and I get 9x squared plus 72x, and then over here I have a positive 7 that I distribute, so I get plus 7x minus 28 all over. I'm not going to combine this. I'm not going to FOIL this out. I'm going to leave it factored because it's easier for me to see if I need to cancel to reduce, or to know what the domain of the function is. So here I have 9x squared plus 72x plus 7x minus 28. I can simplify the numerator one step further by combining my 72x plus 7x, which would be 79x minus 28 all over that factored denominator, x plus 8, x minus 4. Now this is the sum of f and g. But how do I find the domain of this function? Well, again, I'm really only interested in where the denominator of my new function is equal to 0. So because we left the denominator factored, I can just simply take the denominator, x plus 8, set it equal to 0, x minus 4 equals to 0, and I can see that when x is equal to a negative 8 or a positive 4, those are the two numbers that are not allowed in my domain. They cause the denominator to be equal to 0. So we write that as negative infinity to negative 8 union negative 8 to positive 4 union positive 4 to infinity. And if you can't see that very easily, how to write those groups, then go back and put it on a number line. It is a little clearer. So that's how you add the two functions together like we did before, only these were more complicated again because they are fractions. The other instructions I was given for these examples was I already did the sum, so now I want to do the difference. Okay, and I'm going to do the difference over here so we can still see the functions. Remember that if I do the quotient, I'm sorry. I want to do the quotient or division. So f of x divided by g of x is how we do the quotient. F of x is 9x over x minus 4 divided by g of x, which is 7 over x plus 8. Now I can slide it over. Remember that when you're doing a compound fraction like this, the fraction bar is actually division. So if I have one fraction divided by another fraction, then we keep the first, change the sign, so I'm changing it from division to multiplication, and I flip the second. Keep, change, flip. Or in other words, multiply by the reciprocal. So if I multiply by the reciprocal of the denominator, that's what I have here as well. Now that I have this changed into multiplication, I simply multiply numerator to numerator, so 9 times x plus 8, divided by 7 times x minus 4. And that's that is the quotient of these two functions. This is the new function I've created. I can't reduce anything, so we just leave it as it is. But to find the domain of this function, we're going to look at the denominator here. So the domain is where the denominator is equal to 0. So 7 times x minus 4 equals 0. This 7 divides off, and I have x minus 4 equals 0, or x is equal to 4. So 4 is the number that I have to throw out. It's the part that's going to cause the denominator to be 0. So the domain would look like negative infinity to positive 4 union positive 4 to positive infinity. And that's the domain of this new function that we created.